Imagine a computer so powerful that it can solve problems in seconds that would take today's computer thousands of years. This breed of computers is on the horizon, and every country is in a race to seize this opportunity. But the million-dollar question is, who will win this race, and what's the prize for the winner? In our daily lives, we depend on classical computers for tasks like browsing the internet, doing our taxes, and streaming our favorite shows. However, a revolution is unfolding behind the scenes in the tech world. Every major tech company is racing to achieve quantum supremacy. But what does that really mean? Welcome to Nautical Depths. Today, we'll dive deep into the exciting world of quantum computing. The good news is that quantum computers will not replace our familiar devices. Rather, they will introduce an entirely new way of processing information. These powerful machines have the potential to tackle complex challenges, such as simulating biological molecules or breaking codes that safeguard our most sensitive data. When you hear the term quantum supremacy, it refers to the moment when quantum computers can perform calculations that no classical computer could ever achieve. Recently, there has been significant buzz surrounding Google's efforts to reach this milestone, sparking excitement and curiosity about what it means for our future. But why all the buzz and excitement surrounding quantum supremacy? To truly grasp the significance of this achievement, we need to delve deeper. First, we must understand why reaching this milestone has been such a monumental challenge for scientists and engineers alike. It's crucial to explore what a quantum computer actually is and uncover reasons that make building one so complex. What is quantum computing? Quantum computing represents a groundbreaking approach to processing information. It harnesses the principles of quantum mechanics, a field of physics that explores the behavior of extremely small particles, like atoms and subatomic particles. Unlike classical computers, which operate using bits, where each bit can only be a 0 or a 1, quantum computers utilize quantum bits, or qubits. This fundamental shift opens up entirely new possibilities for computing power and efficiency. The power of qubits. At the core of quantum computing lies the qubit, which is far more versatile than a traditional bit. While a classical bit can only exist in one of two states, either 0 or 1, a qubit can exist in a state of superposition. This means it can represent a 0, a 1, or any combination of both at the same time. Imagine being able to flip a coin and have it be both heads and tails simultaneously. This unique property allows quantum computers to perform an astonishing number of calculations in just mere seconds. As a result, they can tackle complex problems that would take classical computers an impractical amount of time, sometimes billions of years, to solve. Superposition, a key concept. Superposition is one of the most fascinating concepts in quantum mechanics and plays a crucial role in quantum computing. It allows quantum systems to exist in multiple states at once. For instance, when a qubit is in superposition, it can be thought of as being both in the state of 0 and 1 until it is measured. This ability to be in multiple states simultaneously enables quantum computers to explore many potential solutions to a problem at once, making them incredibly powerful for specific tasks. Entanglement, a powerful connection. Another essential principle in quantum computing is entanglement. When qubits become entangled, the state of one qubit becomes directly linked to the state of another, regardless of the distance between them. This means that a change in one qubit can instantaneously affect its entangled partner. Such a connection allows quantum computers to perform complex operations and calculations at speeds unattainable by classical systems. This feature can revolutionize how we approach problems in fields ranging from cryptography to materials science. Quantum gates and circuits. Just as classical computers use logic gates to manipulate bits, quantum computers use quantum gates to perform operations on qubits. However, quantum gates function differently. They perform probabilistic operations that rely on the principles of superposition and entanglement, resulting in varied outputs for the same input. Quantum gates are represented mathematically as matrices, and operations on qubits involve multiplying the matrix of the gate with the vector that represents the qubit state. When multiple quantum gates are combined, they form what is known as a quantum circuit, which enables the execution of complex calculations. The potential of quantum computing. The combined power of superposition and entanglement gives quantum computers their unique capabilities. A small number of qubits can represent a large number of states simultaneously, potentially more than the total number of atoms in the universe. This extraordinary parallelism means that quantum computers can solve certain problems, such as factoring large numbers or simulating molecular interactions, much more efficiently than classical computers. As a result, the potential applications of quantum computing are vast, promising significant advancements in fields like drug discovery, climate modeling, and optimization of logistics. Quantum computing versus classical computing. While quantum computing offers immense potential, it is essential to recognize that it does not render classical computing obsolete. Each type of computing excels in different areas. Classical computers are highly effective for tasks requiring deterministic outcomes, such as document editing, web browsing, and various business applications. In contrast, quantum computers are designed for specific, complex problems that are currently beyond the reach of traditional systems. Challenges in achieving quantum supremacy. Achieving quantum supremacy is an exciting goal, but the journey is filled with significant challenges. First and foremost, qubits, the fundamental units of quantum computers, are extremely delicate. They can easily be disturbed by their surroundings, causing errors in calculations. This sensitivity means that even the slightest change, like a tiny vibration or a shift in temperature, can lead to the loss of information stored in qubits. Scientists are working hard to create better ways to protect qubits from these disturbances and to improve the reliability of quantum systems. One approach is to develop error-correcting codes, which are methods that help identify and fix errors in quantum calculations. However, these codes are much more complex than those used in classical computing, making the task even more daunting. Another major challenge is scalability. For quantum computers to solve larger and more complex problems, we need to connect many qubits together. This task is not as straightforward as it sounds. Linking a large number of qubits while maintaining their fragile states is a complex engineering problem. Additionally, the methods we use to build quantum computers, like superconducting circuits or trapped ions, each come with their own set of difficulties. Researchers are still figuring out which technologies will be the most practical for building large-scale quantum systems. Moreover, the cost of quantum technology remains high, making it difficult to access for most people. Quantum computers require special environments to operate, which adds to their expense. Finally, there's a pressing need for skilled professionals who understand both quantum mechanics and computer science. Finding experts with the right knowledge can slow down progress in the field. Despite these hurdles, the potential rewards of achieving quantum supremacy are immense, and the research community is determined to overcome these challenges and unlock the full power of quantum computing. Prize for winner? The race for quantum supremacy is heating up, and many experts believe that the United States is poised to be the front-runner. If the US successfully achieves this milestone, it could revolutionize numerous fields and provide significant advantages. In healthcare, quantum computing could lead to breakthroughs in drug discovery and personalized medicine by simulating complex biological systems and optimizing treatment plans tailored to individual patients. In finance, quantum algorithms could enhance risk assessment and fraud detection, enabling faster and more accurate analyses of market trends. Moreover, in the realm of artificial intelligence, the US could experience a dramatic boost in machine learning capabilities, allowing for more advanced and efficient data processing. The implications also extend to national security, where quantum technology could enhance encryption methods, safeguarding sensitive information from cyber threats. Additionally, the ability to solve previously intractable problems could drive innovations in climate modeling and renewable energy, helping to address pressing global challenges. Overall, achieving quantum supremacy would position the US as a leader in technology, ensuring economic growth and strategic advantages across multiple sectors. The quest for quantum supremacy is not just a technological challenge, it is a pivotal moment that could reshape our world. As countries race to harness the power of quantum computing, the implications of this technology extend far beyond the realm of computer science. If you like this video, then like and subscribe to the Nautical Depths and come back for more content like this.